So the big thing in math is everything has to have an opposite. So all the way back from addition and subtraction and multiplication and division, everything has to have an opposite. So we've been talking a lot about exponential stuff. So we did exponential graphs, we did exponential growth. We did compound interest, which has an exponent. So anything that has an exponent where it's a variable is considered an exponential function of some type. So with this next section, what we're going to talk about is a logarithm, and that's actually the opposite of an exponential. So whenever you're trying to find an exponent that you don't know, that's not just really easy to find, what we use is something called a logarithm. So a logarithm is an inverse of an exponential. So that's why we have these two things paired together. So that's why we've been talking about exponential stuff. So now we're going to switch to talk about logarithmic functions because a logarithm is an inverse for exponentials. So whenever you're evaluating a log or solving a log, what you're finding is an exponent. Okay, so you're finding those hard exponents that you don't necessarily can't just think out loud. Because if it was 4 to the x equals 16, well then we knew that was 2, right? But if you get like 4 to the x equals 18, that's not necessarily an easy exponent to come up with. So eventually what we're going to talk about is how we can use a logarithm to figure out what exponent you can put on 4 that would equal 18. So that's what a logarithm allows us to do. So if you notice with the definition, there's two forms of all of these numbers, one in logarithmic form and one in exponential form. And so what we're going to get used to today is being able to go back and forth between logarithmic form and exponential form, because the big thing is usually inverses kind of look similar, but with logarithms versus exponentials, they don't really look all that close. So if you look here at my definition, and I like to use a cursive L, and I did that for typing wise because sometimes the L up here also looks like a 1. So you don't have to use the cursive L, but I did that so you knew that we're talking about logs, not 1 ohms. Okay, so we're talking about logs. So logs have really two parts. So there's the word log that we shorten for logarithm. Next to every log is usually some sort of base. So it's a little subscript number. So that's why it looks a little bit littler, and that's why a lot of times you use the letter B for that. So there's a little base next to the log. And then we're trying to find a log of something. So next to it's going to be just a normal size number. So again, the way we read this is log base b of y equals x. Okay, so that's the two main parts of a log, and then whatever equals is an exponent. So then what we do is we can take these letters that are in logarithmic form, and it translates into an exponential form. So the base of the log is the base for the exponent. What the log equals is the exponent, and the number that was inside of log is what the exponential equals. So it kind of, I always call it walk around because it kind of goes around kind of in a circle. You start with the base, and then this one we switch, and now instead of having the base next to the y, it's base next to the x, and then it equals the y. And we'll talk more about that when we get to the rewrite part. But again, these two things are considered opposites of each other. I know they don't look anything alike because one has a log and one does not. Okay, one's in exponential form. Again, you can tell the difference between log and exponential pretty easily. Logarithmic form has a log in it. Exponential form doesn't, and it just has a base raised to an exponent of x. So that's exponential form. So again, we're going to get used to being able to take something either from logarithmic form to exponential form or from exponential form into logarithmic form. So we'll be able to go back and forth between these two formats of numbers. So like I said, eventually what's going to happen is you're going to be given an equation, like I said, 4dx equals 18, and be able to translate that into a logarithm to help you solve for x, is what is our ultimate goal with logs. Okay? A couple things about what we can put inside the logarithm. So now we're talking about b and y. So both of these numbers have to be positive. In fact, if you try to do a log of a negative number, it's not going to work. So you can try to type that in your calculator all day, and it'll just say error. So you can't take a log of a negative number. So that's why both b and y, both the base and the number that's with log, have to be positive. And also we don't have a base of 0, because typically we're we're talking about exponential stuff, we generally don't work with 0. Also, we generally don't work with y. It's not necessarily, or not y, 1. It's not necessarily a restriction. But again, typically we don't have a base of 1 when we're talking about logarithms. So there's some definition stuff. Next thing. In your calculator, you probably never wondered, but there actually is 2 logarithm buttons on each calculator. Okay, we have the common log, which is base 10, and that's just the regular log button. So whenever you see regular log on your calculator, it's base 10. Okay, so the way we solve out something that's not base 10, we'll get to that. But again, that's the common log. That's the log that's used most often. So again, anytime you see log on a calculator, it's base 10. And usually they capitalize the L, so that way you know it's a log. Then this another button that's usually close to it. There's another log, but we use it specifically because remember we had E as a number? Well, E as a number has its own special logarithm, and that's called the natural log. And they use the abbreviation LN for that. So whenever you see the LN button on a calculator, it's a log, okay, and it's a specific log, it's base E. So that's why whenever you're having to compute compound interest for continuously, a lot of times you have to hit second LN, because the reason why they pair those two things together is LN and E are opposite of one another. So that's why a lot of times LN or E is often the second feature of the LN button on your calculator. So we can evaluate LN. Again, its only special quality is its base E. So that way, instead of having to figure out how to put an E in as the base for the log, it just gave it its own special logarithm. So that's kind of some calculator buttons. We'll talk more a little bit about in a little bit about how we evaluate using our calculator. So the next thing we're going to talk about is rewriting. So there's 2 main basic things that we can use with a logarithm. And that's rewriting and evaluating. And we're going to talk about both of those today. So the reason why we practice both of these things first, because eventually we're going to use both of these to help us solve those equations that I've been kind of hinting at. So here, notice with all of the things I have up here, for the most part I've given you all numbers, okay? Here's log base 3 of 9 equals 2, okay? We're not searching for anything there. Like I said, eventually there's going to be x somewhere in there that we'll have to solve for, but we're just getting used to being able to take that from logarithmic form into exponential form, or from exponential form into logarithmic form, okay? And I call this the walk-around method. That's not technically mathematical, but you'll see how that works. Okay, so here is our number in logarithmic form. Everyone okay with why that's in logarithmic form? Okay. So if I say something's in logarithmic form, that means it has a log, or if you need to write it into logarithmic form, you need to write it as log. Okay, so here we're going to take it from logarithmic form and rewrite it into exponential form. So the way we do that, we always start with a little number, and we're going to get rid of the log, okay? So the log is going to go away when we rewrite it. So the little 3, everyone watching, listening, pay attention, okay? The little 3 next to the log is going to become our big 3. That's going to become our base for our exponential part of it. Everyone with me? So the little 3 is going to become your big base. And then, like I said, this is why I call it the walk around. So the next number we're going to use is not 9. We're actually going to walk around the equal sign. The next number we're going to use is the 2. Okay? Where 2 goes, that's the exponent of this big base that I wrote. So it's going to be 3 to the second. So make sure you write that as an exponent. Okay? So the little base becomes the big base for my exponential. Then I walk around to the 2, that becomes my exponent on that big base I just wrote. And then what it equals, walk back to that 9, and there's its exponential format, okay? And we've known that one for a long time. We know that 3 squared is equal to 9. So I did try to do some numbers that you would recognize. So these same numbers started off in logarithmic form, and I rewrote it into exponential form, okay? So when I ask you to rewrite, that's all I'm looking for. Being able to go from logarithmic form to exponential form, because eventually we're going to use that skill to help us solve equations. Any questions on the first one? So then the second one, that's again in logarithmic form. Now we're going to rewrite it into exponential form. So where do we start? Yep, the 8. So the 8 becomes a big 8. Then where do we go?
To the 0.
To the 0. Where do we put 0?
You would put it there.
Yep, exponent.
Do we still put it there?
Yep. So no matter what, you start with the big base, walk around, the next number you use is going to be the exponent for that base, and then it equals
1.
that. Okay? And you may not remember the exponential or exponent rule. Anything raised to the 0 power is 1. That's why 8 to the 0 power is 1. Questions about logarithmic to exponential? Alright, so now we're going to do a couple. We're going to go the opposite direction. So this starts off in exponential form. Everyone good with why that's exponential form, not logarithmic form?
Yes.
Okay, good. So, like I said, they look nothing alike. So that's the big thing to get used to. But again, so if it has a log, it's logarithmic form. If it doesn't have a log, it just has an exponent, it's exponential form. So this one, we're going to write it into our own log. So I'm going to start with the word log. And you don't have to use the cursive L if you don't want to. I do so that way you can tell that it's an L, not a 1. Okay? So we're going to write our own log. Again, we start with the base. Where is the big base going to go?
Part of the log.
Yep, it's going to be a little number, kind of a little subscript next to the G. So do try to make sure you format this correctly. So the big base for my exponential becomes the little base on the log. Okay? So again, we're still going to do the walk around. So the next number we're going to use is not that 3. We're going to go around to the 125. So just leave a little space, and you're just going to write 125 like normal. Okay? Just like up here, notice the 3 was a little, but the 9 was just a little space between, and the 9 was normal size number. So we have log base 5 of 125, and then it equals 3. Yep, so we're going to walk back to that 3. That's what the log equals. So we took that from exponential form and wrote it into logarithmic form. Everyone good with that one? Now, like I said, eventually what's going to happen is instead of knowing all these parts, I'm going to put, like I might put, instead of a 9 here, a 2x plus 5. Okay? So then we can rewrite it. So 3 squared equals 2x plus 5. And then we have an equation we can actually solve. Because I always say if there's an x trapped in the logarithm or x trapped in the exponent, the only way we can solve that is by rewriting. So right now we're just practicing that skill, and then eventually we'll use it to help solve for variables. Now this one is kind of already leaning that direction because we already have an x. So here we have e to the x equals 23. So this is one where we'll have to use our weird log. Okay, there is one special log. Whenever you're talking about e, it has its own separate logarithm, and that is the ln, or the natural log. Still don't know why they used ln instead of nl, but I think they try to keep it in logarithmic world, so they started with an L. So the biggest thing to get used to is that if you start off with something with e, when we rewrite it, we use its own special logarithm. So e is going to translate into ln. Okay. Now, typically we write little bases next to the log. Okay. Notice with ln there is no little base here. Technically, if we wanted to write a base, we could write a little e next to the n. So if you want to put e somewhere, that's where you can put it. And I'll put that here for this first example. But typically, when you rewrite ln and e, since ln's only corresponding exponential function is e, typically we just don't write e. That's why whenever you see an ln on your paper, there is no little number next to the n. But like I said, if you really want to write something in there, it's an e. Okay, does that make sense? So e changes to ln because it has its own special log. Again, if you want to write the e there, you can. I'll leave it there for this example, but usually I don't write it there. So then where do we go from e?
You walk
23.
it over to
Yep, so walk it over to the 23. Again, just leave a little space, write 23 normal, and then it equals x. And all we're doing is rewriting it. Underneath it, I'm going to write it. Typically, I would just write it like this. Okay? Because if you're talking about e and ln, when you rewrite e into its log, ln, you don't necessarily have to write the little e. So that's why a lot of times you see ln, or every time you see ln on your paper, you won't see that little e, but technically it's there. Questions about rewriting? So last basic thing for logarithms, being able to rewrite it and then also evaluate it. And so this is just practicing how to use your calculator, basically. So when you evaluate, the common log is what's programmed into your calculator. So when you see that log button in there, what the common log is base 10. And if ever you see a log without a little number, a lot of times, since it's considered the common log, if you ever see a log without a little base, it's a 10. Okay? We like to change things up in math. I know a lot of times what we'll do is if you don't see a number, it's a 1. Well, with logarithms, if you don't see a base, it's a 10. Okay? That's considered common log. That's what's programmed into the calculator. And then, like I said, natural log has its own button. So if you ever have to solve out natural log, there's a special ln key to use. So those are the two main keys on the calculator. So if you have a log that's a different base, so something that's not 10 or not e, the way we do it in our calculator is we end up having to do two separate logarithms. Okay? So if we have log of the base of something, so I'm going to go ahead and jot in an example down below it. So if we're going to try to solve out this, again, if we see a base that's other than 10, we have to do something called change of base. So what we're trying to do, and whenever you solve out a logarithm, what it's finding is the exponent you put on this number, this 5, that equals this number. So it's trying to find those hard exponents, because 5 to some nice exponent is not going to equal 60, because we know 5 second is 25, 5 to the third is 125, so it's going to be somewhere in between 2 and 3. So we're trying to find the exponent you put on 5 that equals 60. Now you can't just type that in the calculator, log 5, 60. The way you have to do it is you actually have to do 2 logs. So the way I'd evaluate this out, I have to do log of 60 first, and then hit my divide, and then do log of 5. So in my calculator, do log of 60 divided by log of 5. Now notice I put parentheses around it because if you're using my calculators like this, when you hit log, it automatically puts a parenthesis by it. So before I type the divide, you need to make sure you close the parenthesis, then hit divide, and then do log of 5. And so what this is it's 2.544. Usually I like 3 decimal places. If I use my calculator up here, I'll kind of show you how I typed it in. Some calculators, and that's why I like my blue calculators the best. If I click that, it's going to show up on this screen. Some calculators you have to type in backwards. So up here, I have to type 60 first, and then hit my log. So there's that log of 60, and you can just leave that program in your calculator. And hit your divide and do log of 5. So I have to hit 5 and log, and then equals, and that's where I got my 2.544 number. Okay. And again, what that number is the exponent you put on 5 to equal 60. So if we did, this is not going to quite work out because we had to round, but if you do 5 to the 2.544 exponent, it gets you really close to 60. So that's what it's finding, are those hard exponents Because if it was just something like this, log base 4 of 16, what exponent do you put on 4 to get 16? 2. Yep. So that's why this is going to be 2. Again, I'll show that in my calculator. So 16 log divided by 4 log. That's why that's 2. Okay? So sometimes, if you're good with exponents, you can think it out and don't have to necessarily use the calculator. Because again, what a log is giving you is the exponent you put on the little number that equals the big number. And so that's why that one's 2. Okay? So, and I'm not requiring you to do some in your head, but you can if you're good with exponents. Does that make sense? So I have a few more examples, so we'll go through real quick. Alright, so when you see ln has its own special button on any calculator that you use. So to solve ln of 6, just type ln6. Up here I have to do 6 and ln, but it's the same idea. Okay? And again, when I want you to round 3 decimal places, so ln of 6 is 1.792. That's just not how I got that. Everybody with me? With me. Okay, so here we're going to log 4 of 64, so we're finding the exponent you put on 4 that equals 64. Okay, you're good with exponents. This is going to be a whole number. It's going to be 3. It's 4 to the 3rd power 64. But again, I'm not requiring you to do it in your head, because you can still do it in your calculator. We can do log 64 divided by log of 4, and that'll tell me that 3. Okay? So like I said, if you're good with exponents, you can think some of them out. Like I said, I already know this is going to be 3, because I know 4 to the 3rd power is 64. But order does matter, so do make sure you're careful with how you type your log in. So we do log of 64, and divided by log of 4. So there's my 3. Again, it's the exponent you put on this number that equals the little number that equals the big number. Alright, here we don't see a little base. So I just talked about what's a little base and we don't see it.
10.
10. Yep, so if it helps, you can write that in. But if you remember, what's the base that's already programmed into my calculator? 10. So you see log 78, all you have to type in is log 78. So that one's 1.892. Going kind of fast. Any questions? So then how can I solve for the last one?
Log 0.125 divided by log of 2.
Yep. So we're finding the exponent we put on 2 that equals the 0.125. So we're going to do log of 0.125 divided by log of 2. So they're not all going to be decimals. You'll get some whole numbers. Again, if you do have to get a decimal, 3 decimal places is what I like for logs. I kind of mentioned this a little bit at the beginning, but if you ever have to take a log of a negative number, it's not going to work. Okay? It's like if I try to take the log of -5, it's going to tell me error. So up here it says invalid input. But again, so if you ever get, if you're ever asked to take a log of a negative number, which I'm mentioning this, you might see that on your homework assignment, it is possible to have error or no solution if you have to take log of a negative, or ln of a negative, either one. So if I try to do ln of -5, it also gives me error. So there is a couple things that you can't take the log of, and that's of negative numbers. Any questions on the basics of logs? So I'm going to hand out your worksheet now.